Recorded as well, and it's Wednesday, April 15th. We got to, what's that?
11-2 now.
Yeah, 11-2. Yeah, we're doing 11-2. So yesterday we did 11-1. It introduced you guys to matrices. So remind you guys what these look like and how these work from yesterday. An example I really like is this one of the first model examples from yesterday. So if you have these different cities with these different metrics, population, income, house size, rent, and you can put all that data into this matrix. Now, guys, this is a 5x4 matrix, right? So, and every one of these data points is called an element. Okay. Okay, so yesterday was just being familiar with, okay, what does that look like? All right, 11-2, we're moving on to some basic operation. It says operation, but really we're just doing real basic. So can you add matrices together? Can you multiply by a scalar value? Okay. Now later on we'll get to multiplying a matrix by a matrix. So that won't be today. So some of you guys got to those questions about in your Alex. Yeah. Speaking of homework, right? So we're going to do these examples today for your notes. That should cover any question you get related to anything in this section. Okay. And then here's your assignment. Yesterday I gave you guys this packet. So just the ones that I circled is all the ones I'm scoring. Right? If you finish these by the end of class, you can turn them in. Probably most guys will need at least another day to work on them. So I'll give you guys tomorrow also to work on these. But just the ones that I circled in this packet. Did you guys get this packet from yesterday? Like this packet has both 11-1 and 11-2 in it. Yesterday we did 11-1. Today we're doing 11-2. All right. So, okay. All right. So write your name on your paper. Name and columns 11-2 notes. All right, so you have to write your name on your paper and 11-2 notes. All right. 11-2.
Turn around.
Okay, so the first thing I'm gonna do with you guys are these right here, was they list these matrices. So okay. Example one here. They're calling matrix A is a 2x2, goes 7, -2, 1, 5. Okay. They give you matrix B is also 2x2. It goes -4, 8, -3, 0. Matrix C is a 1x2. So it goes 9 and 6. And matrix D is also 1x2. It goes -1, -1. Okay, so we got this. We're gonna do this. Okay. All right, so can you add or subtract these? All right, so number 2 says, what is A minus B? So matrix A minus matrix B. All right. And since we know what matrices are, we do that. And so I think that would be 7, -2, 1, 5. And then if I subtract, is that the same thing as plus a negative value? Right. Is it okay if, here, I'll write it this way. So I'll do minus, and here's matrix B, -4, 8, -3, 0. Okay. Actually, this also involves distributing a scalar value, just a scalar value. If I take the negative of this matrix, is it okay if I distribute this negative to all 4 elements? Is that right? Okay. So I'm going to change this to a plus, and then change all these signs. So plus, minus, plus, well, 0 is just 0. Okay. And that's equal to, okay. And then we'll get another 2x2 matrix. Okay. So just add the like elements. So 7 and 4 make 11. -2 and -8 make -10. 1 and 3 make 4. 5 and 0 make 5. That's it. All right, one down. You guys heard that?
Wait, why are you doing A minus B?
Huh?
Why are you doing A minus B?
Why am I doing what?
Alright.
Oh, A minus B? Okay, because number 2 says A minus B.
Oh.
Yeah. Okay. So we're just doing A minus B.
Wait 1 second. I came in a little late.
I don't think you're allowed to do that today.
It's okay.
I'm in the home. No, that's not fair.
Yeah,
That's the line.
Stay on the feet. The other one, please.
All right, guys ready for the next one?
Wait.
Yes?
When it has a lowercase a there, what is it? That's just a variable?
I don't see a lowercase a.
Oh, that's zero.
Yeah, there's a zero here.
Right.
Okay, good.
I think it's gonna be.
Alright, number 3. What is A plus C? Well, guys, A is a 2 by 2 matrix. C is a 1 by 2 matrix.
Yeah.
Do you think you're even allowed to add those together?
No.
No. Alright, so number 3, A plus C is undefined. Alright, that's it. That's number 3. Done.
Oh, why is it undefined?
Okay, because here's A and here's C. Because A is a 2 by 2 matrix, C is a 1 by 2 matrix.
Represents.
Guys, to add 2 matrices together, you have to have the same matrix dimensions. Like before, it was a 2 by 2 and a 2 by 2, so we could just add like element A11 to A11. So in 4 made 11. But if you're trying to add these two together, you can't pair the numbers.
Okay.
Because if the matrices don't have the same number of dimensions, you can't add them together. Okay. Number 5, C plus D. C plus D. So we're looking at 9, 6 plus -1, -1. Oh, I don't know why I put this comma here. Ignore that. Oops. Yeah. This or get rid of that comma. That belong there. Okay, so we got a 1 by 2 plus another 1 by 2. That's going to give us an answer. That's a 1 by 2. What number do you think goes right here? 8. What number right here? 5. That's it. That's the answer. 3 down.
Easy, bro.
All right.
It'd be like pretty easy busy, not gonna lie. It's Mr. Rice, it's very easy.
Yeah. I guess good. It's good. Right now, the next set of examples have to do with multiplying by a scalar quantity, which kind of already did by doing this minus here. Right, so they list these matrices. I'm going to do one that involves H. So let's define H first. So matrix H is, we have a 3 by 2 matrix, 3 by 2. So I'm just copying it straight off the paper. It goes -1, -1, 1/2, 0, 3, -1/3. Okay, so I just copy that straight from the page. Okay, so that's matrix H. Okay. But the question we look at number 11 says, what is 3H? What's 3H? Okay. So 3H, I can multiply by a scalar value of 3. Okay, let's do another 3 by 2 matrix. Okay. I bet you guys can figure this out. What number do you think goes right here?
-3.
Okay, how about right here?
Oh, so -3.
How about right here?
1 and 1/2.
Yeah, great. This one,
0.
this one.
9.
Okay. Or maybe we should call it the element. It says A11, A12, A21, A22. This is A31. And how about A32?
-1.
Yeah. Any question about where any of those elements come from? Here. No.
So you basically just multiply every number by the variable.
Yeah, by this the scalar constant. Yeah.
Yeah.
Okay, so 3 times every number. That's it. Hey, you guys got that? Okay, number 19. We got 4p minus 3q. And okay, they tell you what p and q are here. Okay, so let's get p and q and then do that. So number 19. Yeah, 4p minus 3q. Right. Well, you saw how the scalar played out, so I'll just go ahead and jump straight to 4 times. And then p. I have a 2 by 3 matrix. It goes 1, 13, 15, 0, -3, -3. Okay. And then minus 3q, so say minus 3. I got another 2 by 3 matrix. It goes -1, a half, 11, -1, 6, 2. Yeah. So yeah, let's throw in a middle step. A little 2 by 3 matrices. Guess what number do you think goes right here? Well, I'll just do 4p. So 4 times 1 is 4. 4 times 13 sounds like cards in a deck. 4 times 15. 4 times 0. 4 times -3. 4 times -3. Okay. And then this whole -3 I'll distribute, and I'll say I'm just going to add these two together. So that's +3, -3 over 2, -33, 3, -18, and -6. Okay. Any questions so far?
Just leave that up.
Yeah. All right, let's put it all together. So for the final answer, what is element A11? 7. How about element 12?
3.
Well, here. Got 52 and I have -1.5. It's okay if this is -1.5. Call it 50.5. Maybe take as a decimal. Okay. How about element A13?
What is that?
For 7. Element 21.
That's -3. 3. Normal 3.
Okay.
Oh, shoot.
Element 22.
-30.
-30. Element 23.
-8.
-18. Okay, that's the answer. 6.
First thing to move is. I thought this would be hard to see. This. Oh, mine was not even where you want.
How does it?
Nice.
We touch some now and not.
Alright, everybody gets so far. We're gonna do one more for the notes.
And that we should go over mine.
Number 24.
How about you?
Coffee. A coffee shop sells regular and specialty coffee in 3 sizes.
So.
Got a small, medium, and large. So $1.39, $1.79, $1.99. Okay. But the specialty costs 50 cents more than the regular coffee at the same size. Creating matrix to represent the prices of coffee. Okay, so we have a realistic type scenario here. So I can either create a 2 by 3 or a 3 by 2 matrix. Here, I'm gonna go 3 by 2. Let's do that. A 3 by 2. So let's go regular. And I'll just call it special. Regular and special. All right, and we're going small, medium, large. Okay, so that'll be the 3 by 2 matrix. Gotta spell that out. 3 by 2 matrix. Okay. So they told you the regular prices. It says $1.39, $1.79, and $1.99. So these are all in terms of dollars. And they said the specialties were each 50 cents more. 50 cents more. So guys, what's the price for the small special?
189.
Yeah, 189. It'd be 50 cents more. How about the medium special?
229.
229? Yeah, I think that sounds right. Right? Yeah. Okay, how about large special?
249.
249. Aha. Okay. That's that matrix.
It just looks like the Wawa thing.
Yeah. All right. Okay. All right. And then part B, create a table showing the prices of coffee after a sales tax is applied. So they give you the sales tax, 7.96%.
I live in Katy.
Okay, so we have sales tax is 7.96%. Which means that the multiplying factor multiply by Yes. Okay, yeah. If you wanted to say how much am I gonna pay the government, it would be times 0.0796. Yeah, there you go. But the question is, how much do I have to like fill out of my own wallet? I'm gonna multiply by 1.0796. Right. The one for the coffee itself, that's the money that goes to the store, and the 0.0796, that's what goes to the government. Okay. So let's create the tax matrix. So go so another 3x2 matrix. Okay, so this is with tax. Okay. We got regular, special, got small, medium, large.
This is fucking moron.
So here, I'll do at least a couple calculations over here. So if I take $1.39 and I multiply by 1.0796, and we'll round to the nearest cent. 1.39 times 1.0796. Looking at 1.50. Wow. 1.50. Okay. Let's just round to the nearest cent. 1.5. I'll do another one here. Let's go $1.89 times 1.0796. That's 2.04 something. That's a 2.04. I mean, you guys think you can figure out the rest? Anyway, here. So
I would show teacher at the end of 7 on straight. I just think. You know what I'm seeing about so.
Or just say, we're gonna go to half, or and then hit your 9.5.
Yeah.
You just took an hour.
alright, I'm getting those prices right there. All right. You guys got first o'clock to work on these or ask me any questions if you do. Yeah. And so it's due by end of the week.
Griffin, look